Chapter 10 is a concluding chapter of the statistical course because what we're doing in Chapter 10 is we're inferring using statistical inference to make conclusions about our decision. We're going to decide what we're going to do based on a probability or a percent. Now the two tests that we're going to use, and they are not the only two tests, but the two that we're going to be able to use are the z-distribution, standard deviation of the population is known, or the t-distribution when I know the standard deviation of the sample. Now in order to use these, we have to have this normal distribution. It can come from two things. Either my population has a normal distribution or my sample size n is greater than or equal to 30. We'll be looking at rejection regions, and we have 3 different rejection regions that can happen, and the rejection region is based on the alternative hypothesis. We could have a rejection region to the right or less than, to the left or greater than, or two-sided if I'm not sure if I'm supposed to be greater than or less than. In order to use these tests, I've written some steps. This is a z-test because we use this when we have the population standard deviation sigma. This is a t-test because of the sample standard deviation s. Now again, these tests work if it is a normal distribution. So looking at some problems, if we're going to best estimate the population mean, we're going to do that looking at sample means. And we've got a few problems here that we're going to be doing. So the first one talks about a manufacturer's claim of lifetime of fluorescent bulbs. Now I'll run through this fairly quickly, so you might want to use the pause feature on the video. The average is supposed to be 1,000. I took 40 bulbs and found that they were not 1,000. In fact, they were less. However, I'm testing that they are not 1,000. So I'm going to find a two-sided test, and in order to find that probability or p-value, I need to know my test statistic. The test statistic is how far away I am from this 1,000 in terms of standard deviations. So 980 minus 1,000 is below, so I know I'm going to have a negative z-score. And looking at this, because I'm looking at a sample, I need to take the population standard deviation and divide it by the square root of my sample size. Because I know sigma, this is going to be a z-test. I know the population standard deviation. It was given to me in the problem above. I always complete this looking at my numerator first and then my denominator. And so when I divide these out, I get negative 1.58. What does that negative 1.58 represent as a z-score? Well, it says I am 1.5 steps below my center, and it's also called my test statistic. Because this is a not equal to, it is a two-sided test, and that's telling me I have a p-value on this side and on this side, so I need to double my p-value. So to find my p-value, what I need to do is I look up negative 1.58 in my table, and I find how much area is on this side, and it's going to be about a little bit more than 5%. And because it's a two-sided, this side also has that, so I need to double. Looking at my calculator, if you're using your calculator to find these tests, I'm going to go into stat, test, again it's a z-test. I'm entering my population standard deviation, my sample mean, the sample size, and if I was to only check less than, it would be this 0.569. However, if I go back and do the true test, which was a two-sided test, not a one-sided to the left, I need to select that, go down to calculate, and you can see that the calculator doubled the p-value for you. So that's a z-test. Let's look at the next one here. The next one looks at whether you're getting cheated when you were supposed to receive 32 ounces. That's what we believe the company's putting in. But if they're cheating me, they're putting in less than 32. So I'm only on this side, which would be a left-hand sided test. So I don't need to worry about doubling that p-value because it's just on one side. So let's see. My sample mean, put it down here, my sample mean was less than 32, so it seems like they might be cheating me. Well, how many bottles did they look at, and what was the spread? The spread was 0.7. Now, that was of the population, so automatically I know this is a z-test because of that. And we looked at a sample size of, if we look at the number of bottles that they had in their sample, see, was it big enough? It was 50. So therefore, I can assume a normal distribution. Going backwards for a minute, we didn't address that in this problem. I had a sample size of 40, so I could use the test. I should have stated that. Here, I have a sample size of 50, so I can assume that normal distribution. Using the numerator first and then the denominator and simplifying, I end up with a sample, let's see, I end up with my sample coming out to be 3 standard deviations below center. Center was 32, 31.7 is below by 3 standard deviations. That's very far away. So looking at my test statistic on the left-sided test, I get the value 0.0012. And again, that came right off of my table. If I wanted to use a calculator to find that, I could go ahead and go stat. Again, we're using a z-test. Plugging in information, I should have had 32. My sample was 31.7. My population standard deviation was 0.7. And my sample size was 50. I was using this test to the left. And now when I calculate, I'll see that I had a p-value 0.0012 off my calculator. You can get that right off your table. So now we need to make, looking at these p-values, we need to make decisions. And I better put these in the right spot. The test statistic comes from there. So we need to make decisions on both of these. So on this one, what decision am I going to make? Well, I need to know the alpha level. And the alpha level on here is 0.1%. Alpha is 0.01 or 1%. So looking at 1%, here's where I accept, here's where I reject. Finding this value, it's in the rejection region. So what we need to state is at the 1% level, we are going to reject the null. The data is statistically significant, meaning there is enough evidence to suggest that you are not receiving that amount, that the company is cheating the customers. So let's go back and look at the decision that I would have made on the test above, because we left it just knowing this p-value. And we found our p-value, if you recall here, to be about 11%. So now when I go and look at this alpha level, which is at the 5%, again, this side is still accept, and this side is reject. 11 falls over here. It's unlikely, but not unlikely enough to reject. So here, at the 5% level, we accept the null. Now, there is not enough evidence to suggest. And what are we suggesting in this problem? In this problem, we're suggesting that light bulbs last different than 1,000 hours. So here, light bulbs do not last 1,000 hours. So there's not enough evidence to suggest that they do not last 1,000 hours, so we must assume that they do. The next t-test I'll put on a different lecture.